Mana mana. Mana mana. Mana mana.
Whoa! Did you know that those guys were trying to say monomial? It just came out monomina though. Oh, that Miss W, she's crazy. 4.6 multiplying and dividing by monomials with variables. Don't forget to write the date and don't forget to put your name. Mine's Tara. So here is a little bit of a tricky thing with variables, monomials with variables. Yesterday we were multiplying, or whenever you watch the video, we're multiplying by constants. Now constants, that's a monomial, that has one term, but we're talking about monomials with variables attached, so like 4a, just like we have here, 3a. Before we get into this, I just want us to remind ourselves, or be reminded, or remember, exponent laws. So if I have something like an x times an x, I remember that there is implied to the power of 1 whenever I see a variable. So x times x is just x to the 1 plus 1, which is just x squared. So if I say something like a cubed times a, that's going to be a to the 3 plus 1, which is a to the 4. So whenever we're working with multiplying by a variable, we need to remember to, as long as the base is the same, remember to add the exponents. So let's go on with this one. 3a times 4a. What I want to do is just highlight the things. Okay, we have the coefficients and we have the variables. Now coefficients go with coefficients and variables go with variables. I'm going to multiply 3 by 4, so 12, and I'm going to multiply a times a, so a times a. A times a is just, hey-o, just like x times x is x squared, a times a is just a squared. Put a box around it. I'm happy. Moving on. Question B. 5x times 7x plus 2. Remember Bob Ross, with happy little rainbows, we need to make sure that the 5x, is distributed to the 7x and to the 2. So if I want to write down the long way, if I want to write down every single step, I say 5x times 7x plus, because we have a plus, 5x times 2. 5 times 7 is 35. X times x is x squared. 5 times 2 is 10. X times, well, nothing is just x. That's my answer. Put a box around it. Love it. Now, do I need to have this step right here? For some people, it's going to be really helpful to write down this step. For others, it's not going to be. You just, for the first little bit, I would write this, but after a while, you'll be able to just move from the first line to the last line, no problem. Let's work on this question C. First things first, what I want to do is I feel way more comfortable if the number that I'm multiplying through goes in the front. If you're fine with having it at the back, that's fine, but for me personally, I feel less confused or less kind of thrown for a loop if I put it in front. X squared plus 3x minus 5. Now I'm going to apply this, or distribute this, with my happy little rainbows approach. So a negative 4x times x squared plus negative 4x times 3x. Oh, I'm just going to move over a little bit because I'm running out of room. Minus, because I have the minus here, negative 4x times 5. Now there are a lot of negatives and positives and the mixing of the two, so we're just going to take this real slow with a lot of lines, just so that we don't get confused here. So for my first term, I'm just going to keep it in brackets. The numbery bit is going to be negative 4 because there's an implied coefficient here of 1, so negative 4 times 1 is negative 4. X times x squared is going to be x to the 3. Because if we were to do this on a side note, okay, this could go in your Q's column. I just am not close to it here. So x to the power of 2 times x to the power of 1 is x to the power of 2 plus 1, which is x to the power of 3. So that's just my side work. This is what I would do on a scrap piece of paper. Okay, moving back here though. Plus negative 4 times 3 is negative 12. X times x is x squared. Minus negative 4 times 5 is going to be negative 20. X times, well, 1 is just x. So if I wanted to do this, kind of just show you, it would be x, negative 4x times x to the power of 0, because we could put an x to the power of 0 because x to the power of 0 is always just 1. So that means x to the power of 1 plus 0, which is just x to the power of 1, which is just x. Okay, so that's how we come up with x. If we go down to our next line, let's clean up all these negatives. So negative 4x to the 3, here is a plus minus, that turns into a negative. So minus 12x squared, negative and negative, positive, plus 20x. And you're noticing that I'm doing it in decreasing degrees, so 3x squared, x to the 1. Then, put a box around it. Dividing works very similar. I just want to remind you of exponent laws. If I have P3 over P, that's the same thing as P to the 3 minus 1, which is just P squared. So if I have P to the 3 divided by a P, it's just P squared. Another way that I could think about it is if I have a P times a P times a P over a P, one of the P's in the bottom is going to cancel with the top. So then what I'm left with is P squared over 1, which is just the same thing as P squared. So however you want to frame it for yourself, it works out to the same thing. So I want us to remember to break up into separate terms. So a 15x squared divided by 3x. Now before, in the last lesson, we would have just had the 3 and not the x, but what happens when we do this? So I would say 15x squared over 3x. 15 divided by 3 is just 5. Okay, so we do the numbery bits first. It's just 5. And then we can do the lettery bits. X squared divided by x is simply x. And that's that. Put a box around it. I just want to show you a method too. So breaking up into factors. Because then we can just cancel. So if I would have 15x squared over 3x, that's the same thing as saying 5 times 3 times x all over 3x. So because of this, I can cancel this 3 with this 3, and I can cancel this x with this x, or I could have canceled the last x too, it doesn't matter. And what I'm left with is simply 5x. I like this way Because it really helps me practice my canceling skills that are so important with fractions. However, if this method is, the first method is what works best for you, that's fine, but make sure that you know how to cancel. Okay, so question B, 6x squared minus 4x over 2x. So we want to break it up into the separate terms, which is 6x squared over 2x minus, because we have a minus, 4x over 2x. 6 divided by 2 is 3. X squared divided by x is simply x, minus 4 divided by 2 is 2. X divided by x is just 1. What you mean? X over x is the same thing as x to the 1 minus 1, which is the same thing as x to the power of 0, which is always 1. So this is my answer. I put a box around it and I'm done. Last but not least, let's get to this final question here. Let me just see it so I can write it down. Negative 20a squared b plus 16ab minus 4ab squared over negative 4a. Whew! That one is going to be a bit of a doozy because we have a's and b's. So first of all, let's break it up into the three terms that we see on top. So negative 20a squared b over negative 4a plus 16ab over negative 4a minus 4ab squared over negative 4a. So, negative 20 divided by 4 is 5. A squared divided by a is simply a, and we still have a b left over. Plus, I'm going to put this in brackets because it's going to be negative. 16 divided by negative 4 is negative 4. A divided by a, remember here x divided by x is 1. So a divided by a is 1, and we have a b left over on top. Minus 4 divided by negative 4 is negative 1. Okay, I won't put the negative 1 because we don't need to write a 1 as a coefficient. It's always implied. A divided by a is 1 times b squared. So if I'm to clean up this hot mess that we've made with lots of positives and negatives, we have 5ab minus, because negative beside a positive, a positive beside a negative is a negative, 4b, negative, negative, that's going to be positive, plus b squared. I'm going to put a box around it because I like my teacher. So in summary, when multiplying and dividing polynomial by monomials with variables, use exponent laws to divide and multiply the variables.